Hello, sir. Can we get started?
Sir, Magida?
Yes, sir.
Yes.
Okay. A very good evening to one and all present here. And we are delighted to welcome you all to the seventh session of 2 weeks International Faculty Development Program and on Data Science Tools organized by the Department of Artificial Intelligence and Data Science of SRM Ishwari Engineering College. Today's session is on Power BI. It is an honor for me to introduce and welcome the keynote speaker of the day to our session, Mr. Narayanan Nagarajan, who's currently working as a senior data scientist at Infosys Technology. Mr. Narayanan Nagarajan is expertise in machine learning and computer vision, and he has a direct approach towards problem solving for quick prototyping. He used to implement unsupervised learning algorithms to mine patterns in data rapidly and to create data visualization using open source packages like Matplotlib or dashboards in Power BI. We are happy to have you with us today, sir. The session is yours.
Thank you, Makita. There is a small clarification. Today's session is on Jupyter.
Yes, sir. Yes, Jupyter, sir.
Yes, okay. Thank you, sir. Yeah, thank you so much for the introduction, Makita. I am very happy to join this call and talk to all of you regarding, my learnings in data science and Jupyter in general. This session will be mostly in English, but if any of you feel hard to understand, you can ask me questions in Tamil later in the session. The last 10 minutes of the session, we will allocate for questions. I was born and brought up in Trichy, so I speak Tamil very fluently. And I did my master's in US, worked there for a few years, and then came back here. I currently work at Pune. So feel free to ask any questions in Tamil or English, whichever language you prefer. So I have a notebook with some information to share with all of you. Let me share my screen. Makita, can you confirm that you can see my screen?
Yes, sir. Yes.
Yes, sir.
Okay. Okay. Thank you. So this session will be on Jupyter. I want to briefly explain what Jupyter is and then how a data scientist uses Jupyter every day in work. So what is Jupyter? Jupyter is a interactive web application that allows you to create and write code, equations, create visualizations, and write text as well. So what you are seeing here is a Jupyter notebook. If you see the file extension, it says IPYNB. It means Interactive Python Notebook. This version of Jupyter is called Jupyter Lab, and this is what I use at my office at my work every day. Here I have created some documentation for me to walk through it. So if you see, Jupyter can be used to code in different languages. It's a multi-language interactive computing environment, and it supports 40 plus programming languages. And like I said, this is a must-have tool for any data scientist. So how do you install this tool? How do you get started with it, right? So if any of you are familiar with Python's pip command, you can you install Jupyter using this pip command, or the easier way to install it would be with Anaconda. So Anaconda is a Python distribution, and with if you just install Anaconda, it installs Jupyter, it installs a lot of data science packages. So it's very easy to install and easy to use. So if you are just starting out to data science, to Jupyter and everything, So I would recommend that you get started with Anaconda. So why is Jupyter so popular? What is so good about it? What are the advantages of using Jupyter? So with Jupyter, you can have everything in one place. You can write code in Python or any other language that you want. You can document about your code. For example, like all this I've written here, right? This is called documentation. I have documented something here using Markdown tool, and you can plot graphs. You can do analysis, and based on the graphs and analysis, you can create insights. So that is a main advantage of Jupyter. And then it's very easy to share your work because you have everything in one place, code, documentation, graphs, everything, right? So, and if I have this one file, I can simply send you or somebody else this file and they can look at all my work. So with one file, you're sharing, your entire work on a particular project, for example. The third one is it's very easy to start learning based on others' notebooks. So you can look up online. You can there are some websites that I will share with you where you can look at notebooks written by other people, and you can learn based on their work. And the last one is it can be exported very easily to a PDF or HTML file. For example, if I go here to file and it offers me options like export notebook as. So it can be exported to a PDF, it can be exported to a HTML. And if you're writing code, you want to make it into a script, you can create, convert it into a .py file using this executable script option. So it offers a lot of advantages to convert it into other file formats. Now, okay, now we have talked about what Jupyter is and why it is so popular and so forth. So what can you do with Jupyter? What does a data scientist use Jupyter for? First one is exploratory data analysis. Now, let's say you are starting a new job as a data scientist in a new company. Somebody is giving you a data set and they are asking you to go through the data set and then find some insights from the data, right? That is what a data scientist usually does. They extract insights from raw data, right? So if you are in such a situation, the first thing you will need to do is do something called exploratory data analysis, where you load your data, you clean it up, you find any issues with the data, you clean it up, and then you visualize the data, and then come up with insights. So that process is called exploratory data analysis. So with Jupyter, you can run a piece of code in any cell and then view results immediately. So, for example, to give a quick demo, I can open a new cell here, type something, A equals B plus 1, and I can say B equals 10. Now, if I print B, I can immediately see B's result. And if I print A, it will be 11, right? So you can quickly prototype, you can do calculations on the fly, you can write any code in any block and then find its results immediately. And the next one is Jupyter can cache executions of previous cells, right? So what it means is, so now, like earlier, we had B equals 10, A equals B plus 1, and then we were printing A, right? So now A is 11, right? So let's say I want to find the squared of A. right? So I can simply type and it will give me the square root of A. Because it remembers A's value from the previous cell execution. That's what it means when we say caching of previous cell executions. The third one is data visualization. So you can write code to render graphics and charts. If you attended yesterday's session, my colleague Rahul would have shown you examples from Matplotlib. I'm sure it was a good session. So you can create plots using Matplotlib or interactive tools like Plotly, Bokeh, etc. And then the last one is we can document code samples. So Markdown is a language that allows you to document your work. So this notebook is an example of documentation using Markdown. For example, I can open any cell. I can, I can go to the top. Here it says code. I'm going to change this to Markdown, and I can type anything here. For example, this is a session on Jupyter, right? I can store it as a documentation here. And with Markdown, if you understand Markdown language, you can do a lot of things. Like you can make it bold, or you can make it italic. You can create subheadings like I have created. For example, to create a new heading, you can do something like this. So this would be a new heading. So there is a lot to learn about Markdown and how you can effectively use it to document your work. So this is one example. And with Jupyter, you also have a lot of external add plugins. For example, on the left side, you see a lot of options here. One plugin that I use every day that is very useful is called Table of Contents. So um, we all have done our record works in colleges, right? We have an index for any record that we do. Like I have done record for so many engineering courses, and for every record notebook you'll create an index and specify what is the heading, where it is present, right? In Jupyter you can create a similar index or a table of contents for each block of cell. So when I create a heading here, it becomes a table of content here. If I want to jump to references, right, I can click here and we can go to references. So this is really helpful when you have a very long notebook and you want to go back and forth between different sections. So now we have seen what Jupyter means and what you can do with Jupyter. Now, how can you learn data science and Jupyter? One tool that I would recommend is Kaggle. So Kaggle is an online community of data scientists and machine learning practitioners. So just like you have Facebook for networking, LinkedIn for professional networks, Kaggle is a similar community for data science and machine learning experts or machine learning practitioners, I would say. So with Kaggle, you can view and modify the work of others, and you can also engage in useful discussions. Competitions are really popular in Kaggle, and you can form groups with other people, work on a very interesting competition, and they some competitions even offer tens of thousands of dollars in awards. Um, So if you're starting to learn about data science, about Jupyter or machine learning, I would highly recommend signing up with Kaggle. It's a free online community. You can sign up for free, and you can start looking at how other people are writing notebooks, how they are solving data science problems, and so on. So for today's session, I am going to show an example notebook in Kaggle. And I'm going to show how a data scientist will approach a problem and how they will do all these steps: exploratory data analysis, visualization, and documentation. So this is a very interesting example that I will walk through here. I have left the link here, and I will also share this notebook with all of you in a Google Drive link. So you can also go to the example and look at it later. So with any notebook, we initially import packages that we would need for running the different logic blocks in the notebook. Some popular packages are NumPy, Pandas, and Matplotlib. So these are very common packages that data scientists use every day. Now the dataset that we are going to explore is called World Happiness Index. So every year, an organization will give a happiness index for every country. They will say the people in this country are the happiest, or the people in this country are not happy at all. They are very unhappy. So like that, like we have a data set with the World Happiness Index for several countries, and we are going to explore this data. So here you can see we are reading 3 data sets. The first one is called World Happiness Report. It contains the data for 2021. The second one is a data set that has data for the last 20 years from 2007. So that's a time series data set if it has data for multiple time durations. And the last data set we are going to look into is the population statistics of every country. And this data was recorded in 2020. So we are going to explore these 3 different data sets, visualize the data, and we can derive some insights out of these 3 data sets. And to do all of that, we are using a notebook tool here from Kaggle. So if you download this notebook, you can use it in Jupyter. Here, Kaggle gives you an option to download a notebook. And if you have Jupyter installed, you can open the same notebook and you can work on your computer as well. So let's jump right into the data. So from 2021, the data from 2021, we can see which country was the happiest. It was Finland. And if you look at the top 10 countries that are really happy, 9 out of 10 was from Europe. And if we are looking at the unhappiest countries, 7 out of 10 was from Africa. And Afghanistan was the unhappiest country. So these are some, quick to know facts from your data set. And in order to create this visualization here, we are using Matplotlib. Matplotlib is a visualization package, and the code here allows us to visualize data in this format. Okay, the next question is, we want to know what are the happiest countries in the world. So let's say somebody gave you a passport and a free ticket to go anywhere in the world and be happy. Which country would you go to? Right? All of us want to know this information. So let's look at the visualization here. So these 10 are the happiest countries in the world: Finland, Denmark, Switzerland. And if you see, 9 out of the top 10 countries are from Europe. And if we look at the bottom 10 countries, 7 out of the 10 are from Africa. Now, how did we create this visualization? So this is a bar plot. It is a horizontal bar plot, and Matplotlib gives you options to create plots like this. So if you see, it says bar H. It's a horizontal bar plot. I won't go into the code here to and go deep into the arguments and how to build a visualization. But with Jupyter and Matplotlib, you can create very creative visualizations like this, and derive insights out of it. So one more tip I'll give here. So when you start looking for jobs at the end of your coursework, if you have a portfolio like this in Kaggle or in GitHub, where you did your own work like this, you can share it with companies, and they'll be very interested in talking to you for interviews. So whenever you have free time, you can play around with packages like Matplotlib, with Pandas, NumPy, etc., and then create your own notebooks, either in GitHub or Kaggle. Now that we looked at the data from 2021 and saw which countries are the happiest, we now want to know whether this is the same case for the last 20 years. Let's say we take a look at 2009. Which country was the happiest? Was Finland still the happiest? So we want to look at the change in patterns of happiness index. Yes. So so on the x-axis, we have the happiness index score. And on y-axis, we have the different countries. And for example, I can go through one example. Let's take Germany. So Germany has several data points here in gray. And the yellow data point here means the average score or mean score. And green here refers to the score from 2021. So what is one insight we can derive out of this line here? Germany's mean happiness index is low, but in 2021, it is higher than the mean. What that means is Germany is improving its happiness index score. Maybe in the previous years, it wasn't as happy, but recently, German people are happier than before. So this is a very creative way to show trends in happiness index score over many years. And if you look at Finland, for example, their data points are pretty much always high. It's always over 7 or 7.25. Hence, these countries are consistently happy. So initially we loaded 3 data sets. One of them was population. Along with population, there are several other factors here like life expectancy and GDP per capita. So life expectancy, all of you know, how long we expect somebody to live in a certain country, right? On x-axis you have life expectancy, and on y-axis we have happiness index score. So you might ask, why do we need this plot? Why are we doing this analysis here? Right? If somebody tells you this is the happiest country, don't you want to know why it is happy or why it is unhappy? Right? So there are several factors that affect happiness index, and we are trying to analyze which factors affect happiness index. In this case, we are looking at um, two factors. One is life expectancy on the x-axis, and the size of the dot here represents GDP per capita. So GDP per capita, the higher it is, the wealthier the nation is. So for example, if you see like higher circles here, right, it means those countries are very wealthy. They have a lot of money. Whereas if you see a small dot or a smaller dots like this here, it means those countries are very poor, right? So if you look at happiness index score here, you can see several large dots here, and they also have a high happiness score. What does it mean? So we said that large dots here correspond to a very wealthy nation, right? So what it means is if a country is very wealthy, then subsequently the happiness score also seems to be high. So that is one insight we can derive out of this graph. The second insight we can derive is if you look at life expectancy, the countries that are very happy also have high life expectancy. So it could be because those countries have better healthcare systems. Those countries are less polluted. Uh, those countries have a better climate, things like that, right? So with this graph, we can establish two factors that have a direct relationship with happiness index. Again, this is a very long notebook. I will share this link with you, and you can all go through it in your free time to understand the code and also understand each graph in detail. So we looked at the happiness index by country. Now we are going to look at happiness index by continent. In this case, we are looking at a few states in the Middle East, few countries in the Middle East, and then we also have North America, Western Europe here, and Africa and South Asia here. Now, let's see how continents have their happiness index. So if you see Africa and South Asia are the lowest in terms of happiness index, and North America and Western Europe are the best with respect to happiness index. And then you have some other countries in the middle that are that are in the like they have like a very average happiness score. So you can note down something. I'll come back to it later in the session. So if you look at this graph, there are three colors here because it looks like there are three different categories of countries. I will come back to this categories list later, but for now you can note down there are three different categories. And with Matplotlib and Seaborn is also another visualization package. You can create distribution plots. Distribution plot shows you if you take any variable, how the data varies. For example, I can take one example. If you look at healthy life expectancy, there are two colors here. The red one is for unhappy countries. Green one is for happy countries. And if you see, the happy countries, their life expectancy is between age 60 to 80. Whereas for unhappy countries, it's between 45 to 75. But then if you look at the peaks here, in a distribution plot, the peaks refer to the median, or in other terms, average. They are different terms, but for now we'll assume this is average. So this is another way of representing your data and showing to people how each variable varies for different countries. So the next thing we want to look at is another view where we analyze where all the happiest countries are, given a map. So with Matplotlib, you can, create, like a background of a map, and then you can show different colors on top of it based on whatever data set that you have. So in this case, we can see the happiest countries are, North America, South America, Australia, and North and Western Europe. And you can see that Africa, part of Asia, and India as well are termed as unhappy countries. Now, we would all be surprised to see India in the unhappy list. So let's look at the data and check whether India's happiness scores are really that low. So if you want to look at the data at any time, you can open a new code block, like a new cell here, and you can look at the data frame. A data frame is a data structure that allows you to store data similar to a CSV format. You can see different columns here, different rows here, and the column names are the different countries. So let's look at data for India. So if you see here, India's happiness index has been consistently low. It has been higher in early, the first decade of 2000s, but then very recently it has started dropping. So according to this data, this graph looks right. However, if you go to, if you spend a weekend at any mall or theater, people look really happy, right? People are spending a lot of money. People are going to movies. They're going to beach. People generally are very happy. But this data does not represent the same behavior. Okay, the next one is a really important variable. We are going to look at population. So the reason I'm going through all these graphs, all these factors is if you start a new job as a data analyst or data scientist in any company, this is what you will be doing. You will be analyzing a given data set. You will be analyzing a particular variable like happiness index or some other variable, and you will see what other factors affect that particular variable. So this is a very important exercise that will allow us to understand the data set better. So if you see here, let's analyze this graph. So the red dots here refer to countries that are outside of Europe, regional indicator outside of Europe. And the green dots refer to countries that are present in Europe. And the size of the dot here is based on the population of the country. So if the population is very high, then the size of the dot will also be very high. If the dot is very small, then it means it's a less populous country. So if you see the countries that have really large dots, they have a low happiness score. So for example, this dot represents India. India has a very high population and it has a low happiness score. And this dot is going to represent, I think, China, because India and China are very close in terms of their population. But you can see the countries in Europe have very low population and they also have a high happiness score. So you can say that if a country has low population, they have a good chance of being happy because there are more resources and lesser people to share those resources. So that is one insight we can derive out of this graph. The next, analysis that we want to do is from 2007 to 2020, we have the happiness index score for different countries. We want to analyze how the happiness index has changed over time. What was the happiness index in 2007 and what was the happiness index in 2020? So if you look at a few countries, for example, Denmark had a high happiness score in 2007 and it had a high happiness score in 2020 as well. So there is not much change. It's very consistent. But if you go down the list, you can see several countries that had a huge change in their happiness scores. For example, if you take a look at India, for example, in 2007, India had an index of 5, but now it only has an index of 4. And there are some countries like Bulgaria, which had a low happiness score in 2007, but they are much more happier now. So this is one way to analyze patterns over time. And in this graph, we can see which countries had the biggest change in happiness index over different years. So the countries that had the biggest positive change, meaning the countries that became more happier, are countries like Serbia, Latvia, and Bulgaria. Whereas on the bottom of the list, we have countries like Egypt and Jordan that have become less happier. There is one, this is a good plot. So this is called box and whisker plot. It is used to represent the variation in data. For example, on x-axis, you have the happiness index. I noticed that a lot of people are asking me to share this content. Everything is in my Google Drive. Let me share this link right now in the chat box. So you can download the notebook from here, and I have also linked the Kaggle notebook, so you can go through this in your free time. So this graph shows us how happiness index varies for each country. For example, on the bottom, you have happiness index. And if you look at the data for Western Europe, the box starts at like 6.5 and ends at 7.5, right? That means that Western Europe is almost always happy from 2007. They have always been a happy country. Whereas if you look at South Asia and Africa, their happiness scores have always been low. It is always in the 4 to 5 range. So this is called a box and whisker plot, very useful for making distribution related analysis and insights. The last thing I want to show here is an algorithm called clustering and how you can use it to explore and present your data better. So I'll tell you what clustering means in very simple terms. So let's say you are given a few balloons, and let's say you are given 100 balloons, and you want to categorize the balloons into different categories. Um, so if I gave you 100 balloons, how would you categorize it? You will look at maybe the colors. You will keep blue balloon separately, red balloon separately, or other colors separately, or you would look at the size of the balloon, or you would look at the type of air you can fill in the balloon. So based on these factors, you will categorize the balloons into different buckets, right? That is what we are going to do with our data set here. We are going to categorize the countries into different buckets based on the different features. We have already analyzed a lot of features like population, age, GDP, etc. So we are going to categorize the countries based on those factors. Now, clustering is a very important algorithm that is very commonly used. For example, one algorithm that is very commonly used is k-means. I'm not sure if all of you have already learned it in your curriculum, but k-means is a very popular algorithm that I have also used at work multiple times and gotten good results. So if you want to learn more, you can always read it up online about the algorithm itself. In this case, I just wanted to give a quick walkthrough. For example, in this case, we are using k-means from the scikit-learn package. Scikit-learn is another data science package. And we are using k-means on our data set to categorize the data into different segments. So let's say you have 100 balloons. Now, how many different categories will you categorize them into? Can you make 2 categories, 3 categories, or 4 or 5? How do you determine the number of categories? So there is a method for it called elbow plot, and that allows us to choose the number of clusters or number of categories. In this case, based on the method, we can see that the number of clusters should be 3. So we are going to categorize our data into 3 different buckets and see in each bucket which countries are present and what are their different factors, like why they are present in a particular bucket. So we have run k-means on the data set that we have, and we have 3 different clusters here. And in this graph, we have plotted each variable here, visualized it for each cluster, and we can see so much differences in this graph. For example, if you look at for example, let's look at GDP per capita. So GDP per capita determines how wealthy a country is, and what this is showing is the countries with the lowest GDP per capita are categorized into one bucket, and the countries with an average GDP per capita are present in the middle bucket, and the ones with the higher GDP per capita are in the third bucket. So we can see the clustering algorithm as categorized our data very well, and you can see a similar variation for each of the features here. And if we visualize the same data along with the map, there are three different clusters here. The green ones are the happiest countries. Yellow ones are moderately happy. They are happy sometimes, unhappy sometimes. But the red ones are pretty much always unhappy. So clustering has segregated our data well, and we can also see that in the map. And based on the analysis that we have done, we can arrive at some conclusions. For example, the very happy countries, they are generally wealthy, they have less population, they have fewer children, and so on. So you can read through this. So this is generally what a data scientist will do given a data set. We will load it up in Jupyter. We will analyze the data, make a lot of visualizations, and based on the graphs, we will derive insights out of the data like this. So going back to my notebook, I have attached the documentation for Jupyter here. So you can go here and read about Jupyter, how to install Jupyter, what are the different features of Jupyter, etc. I did not want to give a very theoretical explanation. That's why I opened a Kaggle notebook and showed you how to run the Jupyter notebook and how to create visualizations, how to do analysis on a notebook. And I also attached my LinkedIn profile here. So if at all, if you have any questions, you can send me a message on LinkedIn, and I'll try my best to help you guys out. So yeah, I think which link? Okay, I have created this link. Let me create another link and send it to you. So with this link, I think all of you should be able to access the notebook and also the Kaggle notebook that I showed. You can go here, download the notebook, and you can go through it in your free time. So that brings us to the end of my sessions, and I'll be happy to answer questions. So if you did not understand something, or if you want to know about something, please feel very free to ask. It's okay to ask even if you did not understand something or do not know something. Be bold and feel free to ask any questions.
Participants, the session is open for your doubts. You can post your doubts. Sir, I hope everything is clear, sir.
Hi, sir.
Hello.
Yes.
Hello, sir. Good evening.
Good evening, sir.
Sir, you said Jupyter is a notebook. So it
Yes.
supports all many programming language. Okay, correct. So even though it supports many programming language, which is the most convenient, better to work with Jupyter? Which programming language you prefer? Even though it supports plenty. So which is the best language to work on Jupyter so that?
Sure. Thank you very much for your question. Python is the best language that many people associate with Jupyter because especially for data science, Python has a lot of data science packages that can be readily installed and used for analysis. So Python is the best package. Second best would be R. R is also another popular language. So these two are the most commonly used languages.
Okay. Okay. Thank you, sir. Thank you.
Sure.
I hope everything is clear, sir.
Yes, I see one question to how to export Jupyter Notebook. So Jupyter Notebook. So if you can go to your folder system, file system, and you'll see a notebook like this. Or you can go to File and you can go to Export your notebook as, and you can choose any file format that you want, either PDF and HTML are very common. You can create a PDF of your notebook and share it with anybody. Okay, I think we have answered all the questions. So I would like to thank all of you for this opportunity, and I hope this was a useful session.
So, sir, would like to conclude the session. Sir?
Sorry, yeah, please go ahead.
Yes, yes. Participants, please make sure to fill the feedback sent. And tomorrow's session is on Power BI by Mr. Narayan Nagash, and the timing is from 7 to 8 p.m. Please make sure to attend the session. I would like to conclude the session with a word of thanks. We are delighted to have Mr. Narayan Nagash sir with us today and giving us this informative session. We also want to convey our thanks for accepting and providing support and knowledge. And we thank you for the time out of your time. I would also want to thank all of our participants for taking advantage. Thank you all. Have a good
Yeah, thank you. Bye.
day, sir.
Super.